find giving research talks really stressful, even still, all these years into my project. But I have picked up some tips and advice over the years and found things that I found work for me. And so I want to share those with you in case those can be helpful for you too. So I'm definitely not an expert, but this is just some things to consider when you're preparing slides and during the actual talk. So I'm going to start with kind of talking about the slides and then the talk itself, and some tips for various things that I found helpful. And of course, everybody has their own things, so you need to find what works for you. And so lots of videos and lots of talks and stuff. I'll talk more about that later. But my basic thing is I try to keep, when I'm preparing a talk, I try to make it so that I'm telling a story. So you want to be like taking your audience along on a journey with you. So this is not necessarily chronological experiment wise, and it probably won't be. So you have to figure out the way you want to organize things so that the evidence is building up logically to the conclusions. And speaking of these conclusions, you want to kind of like ahead of time figure out like what are the core conclusions that I want to make and that I want my audience to remember, and then focus on those. And once you have that kind of in your head, like, okay, I want the audience to know this, I want them to understand this. What do I need to show them evidence wise to get them to understand how I drew that conclusion? And so what evidence do you need to show? What experiments do you show that directly lead to those conclusions or that kind of rule out other conclusions? So not like as many rule out things as you would have in like a paper supplemental, but the key things, if there was like two key options and you can rule out one of them and you have evidence supporting the other, that sort of thing. And so you know that you're going to have to leave other things out. So by like focusing on the things that those key points, then you can kind of narrow down what experiments you need to keep in, what data you want to keep in. So it's really tempting to try to cram a bunch of stuff in, especially when you've done so much work. So you have like 5 years of work and you're trying to cram it into the short talk. You're going to have to leave things out. And so you have to focus on the things that, just put in the things that focus on those key points that lead directly to those points that you really need to show that. And then be prepared to discuss and even have backup slides on other things if people ask. So all those other experiments and all that data, you can have those in like backup slides. Typically, you can like skip the slides, have them like skipped in your deck, or you can, what I normally do is I stick them at the end, but I stick a blank slide after my acknowledgement slide, and then I stick these. That way I don't like accidentally like click into these when I'm finished with my talk. And so people aren't going to know everything you found, but they will be able to focus better on the key takeaways than if you tried to cram a bunch of stuff in and they couldn't really grasp the concepts, or they just had it all jumbled up just from information overload. So when you're preparing your talk slides, you want to think about what you want to get across with each slide. So like, what's the point of this slide? Like every slide should have a purpose. And so you want to, how does that slide, what do you want to say with that slide? And then how does that fit into your overall story? And so then how are you transitioning between the slides in order to tell that story? So you can try this out in different ways. I found this be really hard, and I found it really hard to leave out stuff. But so these are kind of like the ideal things that I like to try to keep in mind when I'm doing this, but I'm certainly not perfect at doing all of this. But this was some really great advice that I've gotten from other coworkers and that sort of thing. And I find it really helpful both for you, and I find it more enjoyable as an audience person. So as to the slides, don't be afraid to break slides up into multiple slides, and don't fear blank space. So basically you don't want to clutter your slides. And so you want to focus on optimizing the amount of content rather than the number of slides. And so you might have heard like the rule of thumb or whatever, like a slide per minute. Don't worry about that. Like some slides are super quick if they're just like returning to an outline or they're an animation or that sort of thing. So don't worry about the slide number, but do worry about the number of content. So if you have 2 slides, don't be afraid to have 2 slides instead of squirming, pushing it all into one slide and having a cluttered slide. And so you want your slides to have some open space to help kind of make things clearer and things stand out. And you don't want your audience's like attention going all over the place and trying to figure out where to focus. And you don't want to put a bunch of text on the slide. You want to focus on putting the figures and then explaining them in your talk. And we'll talk more about explaining the figures in a minute. But focus on figures and blank space, not a bunch of text. Don't put like paragraphs and that sort of thing. But as I'm saying, like minimize your text. Also, one of structural biologist's pet peeve, make sure you put, like if you're showing a structural model, make sure you put the PDB ID, so that like 4-letter code or 4-digit code, like 4-letter number code. And very preferably cite the papers. I know that sometimes I forget to actually put the paper citation, but I try to, and at least put the PDB code so people can look it up. And so you can just put like the PDB ID and then the author and the year. But people put a lot of work into those, making the structural models. And so they should get credit. And also it should make it easier if people want to then go and look up the figure. Okay, so we talked about this. So additionally, in terms of decluttering it, this is where your backup slides are also going to come in handy. So if you feel like someone might ask you something about a specific slide, instead of pushing that extra data into that slide, keep it in a backup slide. Okay, so when you're making your slides, you want to make them so that it's going to help your audience follow along. And so what I like to do is I like to title my slides with summary sentences, so that if people like get lost or doze off, which is very, very common, even if you're giving a really great talk, they can still get the key point of what you're showing. And so I like to do like a kind of summary sentence on top of slide, and it also helps you as the presenter kind of know what point you are trying to get them to come across with. And then your job is to kind of explain how the data shows that your conclusion. So to help the audience conceptualize things, try to use graphics when possible. So just like a little, like those working model type of things, like the pictures that they have, like or graphical abstracts, those type of things you might see in papers. If you could just like include those little things as you go, then it's going to kind of help your audience kind of picture things in their head, and where things fit together. Similarly, if you're studying like a protein complex that contains like multiple subunits, and you're studying the different subunits at different slides, or you're studying a pathway and you're studying different components of the pathway at different points, try using graphics to help your audience keep track of which part you're looking at in the slide that you're on. So you can have just like a little infographic with the different parts, and you can have like all the other ones shaded out or just normal, but you have one circled or whatever. Just so as a structural biologist, I come across this a lot because people will be working on like complexes with different subunits, and then they'll be talking about one subunit and then talking about another subunit, and you're like, wait, which one did what? So that's where having those little graphics can help. Okay, so you want to show, explain, and summarize. So when it comes to your figures, you want to be walking your audience through the figures. So when you made the figures and then you spent all this time trying to perfect the figures, and you've done all the experiments for the figures, you're really familiar with these figures, but your audience is not. And so you need to actually, I struggled through this. And I've had my PI, Limor Joshua Tor, is really good about reminding us, like, we need to be sure we explain what the axes are, and explain like how to interpret the data type of thing. There's a lot of different experiment types, and data can be shown in a lot of different ways. So it's really important that this is like a pet peeve of mine, kind of. People, like, I like when people tell you what type of experiments were used to generate the data that you're showing them. So instead of like just like showing binding data, this is binding data, or this is activity assay, I like to to at least tell you like, oh, we did this type of binding assay, we did this type of activity assay, because people might ask you about that, but they shouldn't have to ask you, because you should be telling them. And yeah, no, that's like, papers are getting more and more like that too, where it's really hard to see what type of experiments they actually did. And then you go to the methods and then they're like, we did the methods as these people did it. And then you go to that person, we did it as this people did it. And then we go to that, yeah, you go down this rabbit hole and then you find a paper that's paywalled, from like years and years and years ago. But anyway, from that rant, also make sure you explain any abbreviations that may be unclear. And so when you might give your proteins or something, like I give my numbers, like database numbers. And so when I'm talking about like 5448, it makes sense to me, but other people are like, wait, what? So make sure that you go and you change any of those abbreviations if they're in your figures, or at least clearly show in the figure what it actually is, as well as like if there's lanes and that sort of thing, it can be kind of confusing. Make sure you make it in a way so that they can interpret things, and then walk them through the figures. Don't just expect them to be able to look at them and then be like, voila, I know this. Like when you're reading a paper and stuff, you know how it takes you a while to read a figure. But if you made the figure, you know exactly how to read it, type of like what they should be looking at. So you need to show them what they should be looking at. This is help them follow along. Speaking of helping them follow along, throughout your talk, keep summarizing things, building up a story. So if you have it in this way that you're telling a story throughout, then as you build up, you're building up evidence on top of what you already found. Like, we found this, then it led to this question. So then blah, blah, blah. And so now we can then, when you answer that question, you can then like go back to the beginning, like go back and say, okay, so we found this, and then we found out that this was this because of this or whatever. And then like, so build on it, but summarize it. So the summaries are going to help people follow along, even if they might have gotten distracted, which remember is very, very common. So I like when people like try to make your talk so that there's no like see this or else point. So if somebody like had to go do some experiments, like they had to go take their thing out of the incubator and then they come back and the talk is like a different slide. You want to make sure that people can follow along even if they miss that slide. So having the summaries really helps. And so they might not get everything out of the talk, but at least they'll be able to follow the general story. Okay, so the Q&A part. So this can be really scary. I often find this fun because I just like thinking, kind of. And I like when I'm able to answer the questions. So to do that, I like to prepare ahead of time. So to try to think of questions that people might have and be prepared to respond. And so, especially if you are a student and you have like a thesis committee watching, or if you have like your PI watching, or you have other people in the audience who you know their area, their background, what type of research they do, they're likely to ask you things things about that or things related to that. And so everybody's seeing things from a different angle. They're viewing your data with a different background. And so they're likely to have different types of questions. And so you might not be able to expect those their exact questions, but by knowing like what area what things that they work on, what types of experiments they do, you can get an idea of what type of questions they might ask. You also questions you have yourself that you're trying to figure out, or that sort of thing. So you can come prepared to answer those questions. Keep backup slides if you have extra data that helps address those. But don't panic if you get a question you weren't expecting. Sometimes that's where you can get really cool ideas from that. But also don't panic if you get like a really, really weird question that doesn't really make sense. That's happened to me a couple times. And so this brings us to our next point, which is it's okay to say you don't know. And so you just to say like, I don't know, or I'm not sure, or like, that's a really interesting question. I'll have to look into it, and get back to you if it's somebody like that, would be you'd be getting back to. And so don't make things up. Like just say you don't know. Like you're not expected to know everything. Like it feels like that a lot of the time. But it's okay to say you don't know. One of the things that most excited me when I was in undergrad is when I would ask a question and the teacher said they didn't know. And that, well, sometimes it was because it wasn't known. So that's when it really excited me. But I also like that there's just so much stuff that nobody can know everything, and that's okay. Um, and so you just need to be humble, and don't say things that aren't true just so you sound smart, because some people are going to know that that's not the right answer, and also you don't want to be misleading people in any way. It's okay to speculate, and I kind of like when scientists speculate, because they have other ideas in their head, like the thing like, well, we can't really prove this yet, but this is my hypothesis, or that sort of thing. So it's okay to speculate, but be clear that it's only speculation. Like be clear what you have the direct evidence for and what you're speculating, like how you think things might work. Okay, so now for the actual talk part. Um, so it can be really, intimidating to give a talk, especially as like a student, or a postdoc or that sort of thing. So it got easier for me over time as I got more into my project, but it's always still scary. And you need to try not to let your audience intimidate you, which again can be really, really hard, when you are like a student giving a talk to an audience that contains a bunch of really prominent professors and that sort of thing. But try to remember that it's your research project, and like own it confidence wise. And remember that like, so you know what you did more than those people did. You know what you found more than those people found. They might have different insights. They might know more about various potential implications of it, but you know the work. And try to just like use that to try to like feel a little confident. Remember that even the experts are experts about specific things and not everything. So when you're doing your project, you get like become the expert in this tiny little slice of the scientific universe. You become the expert in it. And those people are experts in their tiny little slice of the universe. So just because they know that really, really well doesn't mean that they know other things really, really well. So don't be afraid to or embarrassed to like over explain or go too basic, so that everybody gets on the same page. I've had sometimes I've had the professors ask me questions that I would be like, wait, everybody knows that, right? And it's like, no, everybody doesn't know that. And so often, also like, I've had professors tell me like, it's okay to explain things more. And so don't be afraid to do that so that everybody follows along. And I really, really hate when people say, like, as everybody knows, or as you should know, like, so everybody does not know. And so I think that saying that is kind of like alienates people and makes them feel stupid. I know, like, it really gets to me when it's like prominent people giving talks to like a general audience. But I know it can be really, really hard as when we're in like these positions as like students and stuff, when we don't want the professors to think that we don't know something that we think that they should. We don't want them to think that we think that they're dumb or, and so there's different ways that you can phrase things, so that you can say those things. Like obviously if you're saying like as everybody knows, then you're saying it for a reason because you want to point it out. So you can say like, just so we're all at the same page or as a reminder, that sort of thing. Um, and so just try to get in the habit of not saying as everybody knows. That's just like a personal thing for me that really I don't like. Anyway, so kind of similarly, remember that not everyone's as in the weedsy as you are with your particular research niche. So you need to explain things in detail and introduce any abbreviations as we talked about before. But remember, like when you're talking about your experiment or something, like people weren't there with you doing your experiments. So you need to explain what you did. People don't know your abbreviations. You need to explain your abbreviations. And so kind of think of think of yourself as an outsider and how you might that might affect things. Speaking of which, try to practice with lab mates or friends ahead of time, who you know will give you honest, constructive criticism about which parts are unclear, etc. And so try to practice with people that are going to be like your audience type of. So if you're giving a talk to like a general, like a campus-wide type of thing, try to give your talk to people from other labs who might, maybe they're in neuroscience or they're something like that. So in our institution, our WISE group, Women in Science and Engineering, they do like practice talks where you can do practice talks with people from other labs. And I found that to be really helpful, so that you could see like what parts are unclear to other people, because you have this story going in your head. You want to make sure that the story is working for them too. And so you also want to try to learn from other people in terms of finding the practices that they do, which you really like, or things that they do, which you don't want to do. So it's good to watch lots of talks and take note of those sort of things. So there's a lot of great talks that you can just watch on YouTube. I know people often talk about YouTube as having like a bunch of like bad scientists you hear, but like people talking down like, oh yeah, they just learned it on YouTube or something. But YouTube actually has some really great science, and they have a lot of like recorded seminars and that sort of thing that you can see and get some ideas. So you want to prepare, but you don't want to like over prepare. So you want to try to sound natural, which is really, really hard, especially for me in the intro section, because there's just so much to cover, and like so you're trying to think as an outsider, like what might they not know and that sort of thing. But then you end up sounding scripty, especially when you're giving like the talk, similar talk, like you give this talk over and over and over again, and each time like throughout your PhD or whatever, but you're getting more evidence and your story is differing, but the beginning, the intro is going to stay pretty much the same. And so it can start sounding kind of scripty, especially if you're also working on like a manuscript, and so you're like writing it down all the time. So you need to remember that you're talking and not writing, and so try to keep your shorten your sentences, and that'll help them seem more natural. And yeah, just try not to over rehearse, which is hard. I sometimes like instead just go over my slides a lot, but don't actually like talk it out. Different people have different things that work best for them. And I find it's a lot easier to get natural once I like get into the part where I'm talking about my own work. And then I can start to like kind of come alive more. So I'm trying to like come alive more in the beginning as well. But you want to speaking of coming alive, you want to let your enthusiasm for your work come through. It's going to make your talk more engaging. Like think about how much better it is to listen to a talk where the person, you can tell that they're excited about their work, and then you're like, wait, why are they so excited? I want to know what they know, because they clearly know something that's making them really excited. And so just let your enthusiasm from your work for your work come through. To try to do this, like, so you can try to avoid looking at the people who make you most nervous. So when I did my thesis defense, I actually had my parents come early and made them sit in the seats that were like directly across from where I would be standing, so that the other people wouldn't sit there, and that I'd have friendly faces to look at and not people who intimidate me. But do try to think about your audience. If you're doing a live talk, look at your audience, point to things on the slides with I love laser pointers. Oh my God. I got a laser pointer for like Hanukkah. Really excited. But anyway, try to keep engaged and not just like stare at your screen if you're giving a live talk. I know it's really hard when you're kind of going back and forth between Zoom and live. I had trouble with that when I was preparing my thesis talk, because it was going to be live. I mean, like in person. Well, it was hybrid. But I was like looking at my screen, and then they gave me a laser pointer, and then I was looking at that and engaging with the audience more, and it went a lot better. And so yeah, so I was doing that in a practice talk, which brings me to my next thing, which is like when you get feedback from practice talks, this can be really helpful, but don't panic if you forget to include someone's suggestion. So they made, like my lab mates made a bunch of really great suggestions, and I was like, oh my God, what if I forget their suggestion? And then they're gonna think I ignored them. So just try not to panic. And a couple of things. So like remain calm when you forget a word. And so this can happen. Like my dad does radio, and he's the one who was really helping me with this when I was doing my practice talk, because I get really flustered when I forget a word or lose track of where I went to go. And he taught me that instead of stopping and starting over, you just need to like power through. And so keep going when you lose track of where you're trying to go, and then you'll get like back on track. I know it sounds really hard, but if you make a bigger deal out of it than it really is, then your audience is going to make it bigger. It's like more of a big deal if you make it a big deal. So they don't know where you're trying to go. They don't know the word you forgot. And so you can kind of, you're psyching yourself out more than you need to probably. And I think that's basically it. So yeah, you just need to kind of find what you like and what works best for you, and really just try to remember why you're so excited about your work, and help them see why they should be excited too, and take them on that journey with you. So do that summarizing along the way, explaining things well, and just try to have a good time if you can. And remember that the Q&A, although it can be terrifying sometimes, it can also be fun, because you get the chance to kind of um, show that you know what you work with, and also you might get some really cool ideas for future experiments. And so yeah, and hope that helps, and happy talking. And I've got to go back to preparing for my talk. Bye.